What is going on, guys? Welcome to your 23rd chemistry tutorial, and in this lesson I'm going to be talking to you guys about nuclear fission, the technology that is responsible for all of the nuclear plants in America today, and also is responsible for some atomic bombs. So I know you guys are probably salivating over that thought. So basically, what nuclear fission is it's when an isotope breaks into two or more elements. In other words, whenever you have the nucleus of an atom and it breaks up into some smaller stuff, that's the process of nuclear fission. Now, nuclear fission happens every day in nature all the time. However, since this process gives off energy, scientists wanted to kind of find a way to harness that energy pretty much so they could sell it for some cash. So what they did is they found out that two isotopes in particular work really well in nuclear reactions. This is uranium-235 and plutonium-239. And I'll talk to you guys about why these two isotopes work so well later on. But for now, let me show you guys visually what goes on inside a nuclear fission reactor. So basically, we'll say that this blue and green nucleus is the nucleus of uranium-235. So here's a nucleus of uranium, and these three are all uranium right here. So what they do is they have a bunch of uranium-235 and they go ahead and they strike it with a neutron. Now the reason they have a neutron is because you can't have anything that's charged like an alpha particle or something. Since this is a nucleus of uranium, it's positively charged. It has protons and neutrons in it. So if we would fire another proton in here, let's say, then since this is positive and this would be positive, they would repel each other and it couldn't blast into it. So that's why we choose a neutron, because a neutron has zero charge. It could collide with this nucleus easily. There you go. So basically, whenever we have this collision that happens, the uranium nucleus becomes instantly unstable and breaks apart. So uranium-235 can actually break apart in several different ways. However, uranium-235 typically produces two lighter elements, as we can see with this red and white and green and red. And it also typically produces two or three additional neutrons. That's why they have to use uranium-235, because it often splits in this very particular way. And this is very important because whenever you have these new neutrons, then those new neutrons, those additional neutrons, are free to collide with other atoms of uranium-235, causing the same reaction over and over and over again, and we call this a chain reaction. With other elements, we can split them apart, but they don't produce these additional bullets, so the reaction kind of just fizzles out. With this, it takes only one small amount of energy, this one neutron being fired in, to produce this chain reaction. And remember, I just show arrows here, but this, whenever this splits apart, is going to produce more elements and other neutrons to go flying over. This is going to produce other neutrons to go flying over. This is going to produce other, and it's just going to happen into this big, huge chain reaction. So that's the beauty of nuclear fission, that you can make an incredibly small amount of energy and turn it into a huge amount of energy. Now remember, we are only looking at four nucleus right here, four pieces of uranium basically, but remember, there are a million atoms in just the width of your hair. So it really doesn't take a big sample of uranium to produce a huge reaction. So you're saying, okay, I understand how you can have a neutron burst into the nucleus of uranium and it will produce two smaller elements as well as three additional neutrons, but where the heck does the energy come from? I don't see how this would produce energy at all. Well, let me go ahead and answer that question for you. So as soon as the uranium nucleus splits, the new elements, if we look at, these are two nucleus or nuclei from two different elements. Since this is positively charged and this is positively charged, before they were all one element and they were together. The force was holding them together. However, now that they split apart, they are two positively charged nuclei and they're going to repel each other. So whenever two things repel each other, it's going to cause motion, which causes kinetic energy, which produces heat. So basically, they're all held together by the force or the glue before, and now they're going to break apart, move apart, which is going to produce kinetic energy, which was before potential, and that movement is going to cause heat. So this causes a lot of heat. Now, aside from that, it also produces gamma radiation. Now, in addition to the heat and gamma radiation, depending on how this uranium nucleus split apart, these two elements, or depending on the isotope that it makes, the new elements may also emit beta radiation or gamma radiation. So basically, you're guaranteed to have at least gamma radiation and also kinetic energy and therefore heat. And aside from that, you also may have beta radiation and gamma radiation coming from these new elements. So with all of that, that is how it produces energy in nuclear fission. So hopefully all of your answers with nuclear fission are answered now. In the next tutorial, I'm going to be talking about nuclear fusion, which is basically taking two different elements and pushing them together into one bigger one. And the way that that makes energy is totally different, and that is supposed to be like the future energy of tomorrow, the perfect energy. So that's what we're working for now, and by we, I mean chemists all across the United States and all over the world. But we have not gotten to that point yet. So I'm going to be talking about all that in the next tutorial, so that's what you guys have to look forward to. But anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys later.